The size of the ground wire for multiple motors in a single conduit is determined based on the ampacity of the largest motor in the circuit. Here are the steps to determine the ground wire size. Firstly, identify the largest motor. Determine the motor with the highest full load current or flaw in the circuit. Secondly, calculate the ground fault current. Multiply the FLA of the largest motor by a safety factor of 1.732. The formula is ground fault current equals FLA times 1.732. Thirdly, determine the required ground wire ampacity. The ground wire must have an ampacity equal to or greater than the ground fault current. Fourthly, use ampacity tables to select wire size. Refer to ampacity tables for conductors and conduit to determine the appropriate wire size based on the ampacity required. Here is an example. Assume there are 5 motors with the following FLA. Motor 1 has 2 amps, motor 2 has 3 amps, motor 3 has 4 amps, motor 4 has 5 amps, and motor 5 has 6 amps. 1. The largest motor has an FLA of 6 amps. 2. The ground fault current equals 6 amps times 1.732, which equals 10.392 amps. 3. The ground wire ampacity must be at least 10.392 amps. 4. According to ampacity tables for number 14 American wire gauge THHN in conduit, the ampacity is 15 amps at 90 degrees Celsius. Therefore, a number 14 American wire gauge THHN wire is sufficient as the ground wire for the 5 motors in a single conduit. This example highlights the importance of using the largest motor's FLA to determine the appropriate ground wire size, ensuring electrical safety and compliance with codes.